Welcome viewers, welcome to the new lesson from Dr. Arts Biology. If you did not subscribe the channel, you can just click on the subscribe button and bell icon. Welcome students, let us see the structure of Fmn and Fad first, and then we will be moving into the importance of Fmn and Fad. Before that, make sure that you are knowing the structure and importance of ATP, cyclic AMP, UTP, NAD, NADP. Okay, so make sure that you have learned it and then you are coming here. Clear? So we can see the structure and importance of Fmn and the Fad. So first of all, the Fmn. So what is there in Fmn? You can see that the full form of Fmn is nothing but flavin mononucleotide. And we know the flavin, riboflavin, so vitamin B2. So it is actually there, and then ribose sugar is there, and then the phosphate group is there. So that's why flavin mononucleotide. We know that nucleotide, sugar will be there, then phosphate will be there, then a nitrogen containing molecule will be there. That is what actually mean by the nucleotide. So flavin mononucleotide, only one nucleotide is there, that's why mononucleotide. Now the riboflavin is not in the exact form. Okay, it will be in the derived form only, and also ribose sugar will not be in the ribose form, instead it will be in the ribitol form. Phosphate group will be exactly same. So it contains flavin plus ribitol plus phosphate. Don't worry about ribitol. It is similar to ribose only. Okay, so our problem is when you are seeing a new thing, accidentally or unknowingly you will be having attention. So we have to learn that structure also. So you don't worry about all those things. Ribitol is exactly same as the ribose only. We can see the ribitol here. Okay, so ribitol, ribose sugar. We know ribose sugar is having CHO, CHOH, CHOH, CHOH and CH2OH. This is a ribose. Now what will happen when it is converted into ribitol? You have to see that all, definitely it will be an alcohol. When a sugar will be converted into alcohol, when it is getting reduced. So ribitol is nothing but the reduced form of the ribose. So where it will be happening, reduction will be happening where? So only one possibility, that is in the functional group. So if you are just adding 2 more electron and hydrogen to the functional group, it will be reduced and it become alcohol, and as a result it is ribitol. So you can see that this CHO should change as CH2OH. So CHO, what is remaining? 2 hydrogen along with the 2 electron that you cannot see here, but it will already there. Okay, along with the proton it will be electron also. So CH2 should be added, that's all. So it is nothing but the reduced product of ribose. Ribitol is nothing but the reduced product of the ribose. So we can just change it. Make sure that you are drawing this particular structure. Then you are redrawing it as the ribitol, so that you can ensure that you know what happened. Okay, so what happened? I am just saying. So what will happen? 2H plus 2E minus V is added, and as a result it becomes CH2OH. Okay, CH2OH. That is what actually the ribitol. Now this is the ribitol. Okay, the previous one is the ribose and this one is the ribitol. Clear? Now the question is about the flavin molecule. In order to draw the structure of flavin, you don't have to worry much. We can just think about, I'm just drawing it there. I'm just utilizing this place so that we can just completely draw the Fmn. First, you have to draw a benzene ring. Okay, for understanding the flavin structure. So, step by step, if you are understanding, you will not be forgetting that. Ensure that it is having 3 rings. First, we have to draw a benzene ring. Okay, then you have to draw, leaving a space, you have to draw the uracil. You know, N is the, N is here. Okay, uracil. And we know hydrogen will be there, double bond O will be here, double bond O will be here. Now, connecting these 2 rings, you have to make a nitrogen bridge. Simply like this. Okay. So, 2 ring is there, 3 ring is there in this way. Clear? Now, let us see what are the other changes. So, you have made a uracil here. We will be just balancing that this one. So, valency will be filled up. Before that, I am just explaining what will be the uracil is the, benzene is the, connecting that to a nitrogen bridge is there. Another hexagonal structure. Okay. So, we can see what are the extra thing. So, we have to keep in mind this thing. Here, one CH3 will be there, and here, one CH3 will be there. The remaining entire portion will be filled with the hydrogen, and you can just make the double bond. So, this region will have a hydrogen. So, we need a double bond here. Okay. Now, this particular portion also we need a double bond. Okay. So, 1, 2, 3 is over. So, what we need a hydrogen here. And in this portion we need a double bond. Okay. And where we can have a double bond should be here, and a double bond should be here. So, in this position, hydrogen will be there, but that will be utilized to make the bond. I am just drawing hydrogen. When we are drawing the structure, we will be just removing that to leave the hydrogen. Now, what is remaining? This one, there is no possibility double bond, and this one double bond is over. So, entire structure is complete, right? So, that's about the niacin part, flavin part of the flavin mononucleotide. Now, we have to see this particular structure there. So, I am just drawing the riboflavin part. Okay, so it's having CH2OH. So, OH I am drawing here, and then C, H, C, H, OH. So, I have drawn CH2OH in this way, CH2OH. Okay, don't forget that. Then C, H, OH. And then again 1, 2, 3, 4, 5, 1, 2, 3. Again CH, OH, 4 only. Then again CH2OH. CH2O. H. Okay. Now what we need? We need a phosphate group more. Okay, one more phosphate group we need. So that we will be adding here. So H, O, P, double bond O, O minus, O minus. Just to know how the bond is formed, I am just making it. Now what will be happening? This particular thing will be released as H2O, and this one also will be released as H2O. Okay, so pause the video and draw this particular structure. When you are drawing by understanding, I am repeatedly saying, when you are drawing by understanding, when you are learning by understanding, it will be there. If you are just writing the final structure, you will not know how it is formed. then you have to by heart the structure. The problem will be happening. You will be having confusion later. So better you draw it one by one and ensure that you are learning it properly. Okay, so then you have to pause the video and draw how these particular things are forming. Okay, I will not be redrawing. I will be just making changes in this figure only. But you have to redraw that particular figure. So let us see what will happen. Due to the loss of water, a bond will be formed between this carbon and this nitrogen. And due to the loss of water, a bond will be formed between this carbon and this oxygen. Okay, so let us see that particular thing. I am just erasing. Make sure that you have drawn in this way, and then only you are drawing the final structure. So I am just making the bond. Okay, the bond will be formed between this nitrogen and this carbon. So you can just make nearby, draw it nearby. Okay, as I have to show the water release and all, I have made it like this, but you can just draw it nearby only, and is also nearby. Okay, so this is actually the bond, this particular Fmn, flavin mononucleotide. Now the question is, we know that Fmn is also acting as the reducing power or oxidizing power. So a reaction site should be there in this molecule. Just like we have seen the reaction site in NAD plus and NADP, a reaction site should also be here. So this reaction sites are and making it in the red color. Okay, so you can just draw it in a different color so that you will understand the reaction site. These two nitrogen are the reaction site. So this is the reaction site 1 and this one is the reaction site 2. Okay, so that's about the structure of Fmn. Now we should know what will happen if it is getting reduced, if the hydrogen and electron is added. So what will be the structure of FmNH2? I'm just drawing FmNH2 here. Okay, so make sure that you are having, I will just make a click. So you can have you pause the video and have a drawing like this. I'm not making a screenshot. Instead you can just pause the video and you can just draw the structure again, because I am going to erase this particular part. Okay, so let us see what will be the structure. I am just making this entire part as the R. Okay, so let us see what will happen if reduction happens. Okay, so if 2H plus 2E minus is added, if it is going to get reduced, what will happen? So we have to draw the N, and then uracil, N. Okay, double bond O. Here, one hydrogen will be added. This particular hydrogen will be added at this point. Okay, and here also we know that no more hydrogen there. One hydrogen will be added here. I'm just making it with a different color so that you will understand. So I'm just making it 2H plus 2E. So I'm just changing it as the blue H so that you can understand this H plus is here and this particular H plus is here. Okay, the remaining structure is same only. You will be having a connection with the ribose. So CH, OH, CH, OH, CH, OH, CH2, O, P, double bond O, O minus, O minus. Okay, so you got it. And the remaining you can just fill the entire structure. What will be happening? CH3. And what is the hydrogen? What valency will be feeling like this only, but the bonding at this position will be changing. We know that this nitrogen 3 valency is already filled. Okay, then what will happen? And this nitrogen valency is also already filled by addition of hydrogen here and there. So this double bond and this double bond cannot be made there. Instead, the double bond will be changing into this position. Okay, the entire remaining structure will be same only. So you don't have to worry about anything else. So hydrogen is there. So this is actually the reduced form of Fmn, and that is nothing but FmnH2. FmnH2. Here we are just writing FmnH2 than FmnH plus H plus because both hydrogen is added, no proton is out. In case of NADH plus H plus, 2 electron is added but only 1 proton is added. And the 1 proton is out. That's why we are just writing NADH plus H plus. Here you don't have to write like that because both hydrogen are added in the molecule. So this is the reduced state. Hope you got it. Okay. So same will be the reduced state of the FAD. There is no change in that except the addition of an adenine nucleotide there. The reaction site is not there in the adenine nucleotide. Instead, it is there in the flavin part. Okay. So we will be just adding one more adenine nucleotide there in addition to the Fmn. Then it forms the FAD. Clear? So let us see the structure of FAD then. Make sure that you are learning in the proper way so that you will not have any confusion later. Okay. Try to draw it yourself, then only it will be there in your brain. If you are just hesitated or if you are worried about whether it become wrong or not, you will never learn the structure. Try it and correct it. Try it and correct it. That is the only possible way. Clear? So let us see the structure of FAD. I am just changing this figure into FAD. Okay, but you don't do that. You have to redraw it. Okay, don't be at ease. You have to redraw it. I am just changing in order to save the time. I am just changing this figure itself into this thing. Okay, the FAD. So let us see. So this part we know that this part will be. I am just taking this itself so that we will understand what exactly that will be forming. So this part I am just changing. The entire region will be same. Okay. I am not showing how the bond will be formed and all because we have already learned in Fmn. So you don't have to repeat it. So this one I am just going to deal with the flavin adenine nucleotide. So flavin adenine dinucleotide. So the name will be just changing. Adenine dinucleotide. Okay, flavin adenine dinucleotide. So what will be the flavin ribitol phosphate plus what will be the adenine nucleotide will be the adenine nucleotide that we have learned in NAD and all. So I am just drawing the adenine nucleotide. So in addition to flavin, ribitol and phosphate, what will be the adenine, sugar, ribose sugar and phosphate will be there. So let us see the structure of FAD. So we have to just make H, C, H, OH, C, H, OH, C, H, OH, C, H, 2, O, and I'm just adding phosphate group. Okay, double bond O, O minus, and again I have to link it with what? Adenine nucleotide. So phosphate group of adenine nucleotide should be attached there. Clear? So I'm just making the phosphate group of adenine nucleotide with the P, black in color. So double bond O, O minus, and this O will be linked with the ribose sugar. Okay, this O will be linked with the ribose sugar. Let us see that. I'm just erasing this particular part, otherwise we cannot draw it. Okay, CH2 should be here. And then what should be the hydrogen? Then ribose. Beta ribose. As a result, O should be on top, and this one will be linked with the adenine. Okay, so adenine is there. Now adenine amino group is there on the top. Hydrogen is there. Hydrogen is there. Double bond here, double bond here, double bond here. Hydrogen. Okay. So this is actually the flavin adenine dinucleotide, where this particular part actually represents the flavin mononucleotide, and this particular part is actually representing the adenine mononucleotide. Okay, when it comes together linked through phosphoanhydride bond, it will be known as the flavin adenine dinucleotide. Hope you got it. Okay, so all together it is FAD. Now what will happen when reduction happens and what will happen when oxidation happens? This is an oxidized state. What will happen when reduction happens? I am just drawing this particular part. We have already learned in the Fmn, the same thing is happening. So ensure that you are drawing this particular structure first. Okay, just pause the video and draw this particular structure finally. Now you can just redraw the same thing by making an R here and drawing only this part and adding hydrogen. Okay, so where the hydrogen will be added? So hydrogen will be added here. Hydrogen 1, hydrogen 3. And electron also should be added. As a result, this double bond will be changing its position into this particular region. This is the structure of FAD. Clear? Now this one is FADH2. So you have to draw the first figure and then you have to redraw this particular figure. Try drawing, then you will be inside the biochemistry and you will be more interested to learn. That is a way to make biochemistry interesting. Okay, we will be having a pleasure when we are doing something that we believe that we cannot do. Okay, so the same thing will be happening in you if you are trying to draw the structure of yourself for some biochemical molecules, and initially you will be having so many mistakes, and finally you are achieving that particular structure without looking into any book, and you are in a state to draw the structure at any time. You will have that pleasure, so make sure that you are getting that pleasure by practicing drawing the structure. Okay, let us see the importance of Fmn and FAD now. We have to keep in mind that the importance of Fmn, FAD, NAD, NAD plus, etc. are same only. There is no change in that, except some enzymes will be specific to NAD plus, NADP, and some other enzymes will be specific to Fmn, FAD, etc. Now, what is the difference between NAD, NADP and Fmn, FAD? In the reaction which are releasing lower energy, the Fmn or FAD will be the part. In the reaction which are releasing more energy, NAD or NAD plus will be the part. Okay, so you should understand that basic difference. Otherwise, everywhere you can find Fmn, Fad, NAD, NADP as the source of electron. Okay, so let us see the first importance of Fmn and Fad. That is nothing but the first importance that you have learned in NAD plus, that is it acts as a coenzyme. There is a coenzyme for what? Dehydrogenase. And in what kind of reaction? Redox reaction. So it acts as a coenzyme for dehydrogenase enzyme in redox reactions. We know what is meant by dehydrogenase, what is meant by coenzyme and all. Just to watch NAD and NAD plus if you don't remember that. I am not saying it again here. Now, what is the second part that we have learned there? It acts as the electron donor or electron acceptor. It acts as electron donor when it is in reduced state. What is the reduced state of Fmn and Fad? It is nothing but FmNH2 and FADH2. Okay, and it acts as the electron acceptor, where in oxidized state. What is the oxidized state of Fmn and Fad? It is nothing but Fmn and Fad. Fmn and Fad. Okay, so what is the next one? Now the basic difference between Fmn and Fad comes. If a reaction is actually releasing, a redox reaction is actually releasing an energy which is lesser and which can be stored in the form of electron transfer potential. You have to make sure that you are knowing that particular factor. NAD, NADP, Fmn, Fad, etc. will be acting as the energy resource, high energy compound. They will be storing the energy in the form of electron transfer potential. And that electron transfer potential will be utilized in oxidative phosphorylation. You will see that in metabolism part. And through oxidative phosphorylation, this electron transfer potential will be converted into ATP. Okay, so the energy is stored in the form of electron transfer potential, which is converted into ATP in oxidative phosphorylation. So that is the case with the NAD, NADP, Fmn, Fad, etc. Clear? So I told you that NAD and NADP will be having higher energy state compared to Fmn and Fad. If the energy resource is lesser, what will be happening? Fmn and Fad store the energy, okay, in the form of electron transfer potential. And which will be equal to 1.5 ATP. Okay, in case of, you have to keep in mind, in case of NAD and NADP, we will be having an electron transfer potential energy equal to 2.5 ATP. Okay, this you keep in mind for the NAD and the NADP. So they are storing energy released in redox reactions in the form of electron transfer potential, which is equal to 1.5 ATP. That will be retrieved in oxidative phosphorylation. Okay, so hope you understood what I mean. So Fmn and Fad. So if the energy is stored, what, in which form it will be? It will be in reduced form, FmNH2 and FADH2. Okay, so that's about the importance of Fmn and Fad. Hope you understood the concept. So that's the end of high energy nucleotides. Okay, biologically important nucleotides. Okay, now let us see. So after this particular lesson, you have to observe, or you have to watch, or you have to learn the lessons from the metabolism. So now we are going to start the metabolism part. where carbohydrate metabolism is there. Okay, so we'll start with the carbohydrate metabolism then. So I'm just repeating what is the way to learn the biochemistry. So from unit 2, the continuation will happen. Unit 2, you have learned carbohydrate first. After that, you have to learn the unit 2 topic 4 enzyme classes. After that, you have to learn, unit 3 topic 1 enzyme classes. And then after that, you have to learn unit 2 topic 4, what? The same thing, biologically important nucleotides. Then you will be going back to unit 4 metabolism of carbohydrate. Then you will be going back to the protein. Then protein metabolism. Then lipid metabolism. Then completion of the remaining portion of the topic 4. That is DNA structure, RNA structure, etc. So this is the way that you have to learn the biochemistry. If you are moving like that, continuation will be there and it will be easy for you to remember the things. Hope that particular thing is helpful for you. This particular lesson is helpful for you, and make sure that you are learning properly. Thank you for watching. Okay.